Hello and welcome to this edition of NLB's Tech Tip videos, a video series where we go a little bit deeper into some of the products and tools that NLB has developed over the years. My name's Jim Van Dam, and today I'm joined by Anthony Wojciechowski. Anthony is the manager of our R&D department, and he's joined me today to talk about NLB's ultra-high pressure swivels. Anthony, what is an ultra-high pressure swivel?
Well, this is an ultra-high pressure swivel, and it allows us to take 40,000 psi, up to 40,000 psi, and rotate the output of it. So you can imagine if you're trying to clean something with a single jet, it would take forever. You have to move it all over the place to get coverage. Yep. Well, this moves it for you basically, and allows you to cover a larger area with the limited amount of ultra-high pressure water that you have.
And that is the magic of rotation in water jetting. Anytime you can take one or two or more jets and rotate them, you can start to get a lot more coverage than you can with a single jet.
Correct.
And rotation has been important to NLB for years. The first rotation tool was the spin jet, which was really a key in NLB's growth when it came to the automotive paint shop. So there's been a long history of NLB rotation. Today we're looking at two specific, and these two are ultra high pressure. Let's start with what we have today, which is the NLB DS8850 swivel.
Yeah, as I showed you before, this allows you to put high pressure water in one end and rotate the output of it here. So we have, this is the input side. We've got a few different options here for input, and it's just changing this piece here, this inlet adapter.
Okay.
And then we have different options for the output shaft as well, depending on what tool it's being used on. I can actually take this apart very easily and show you.
And this is how you would replace the seal in this tool, right?
Correct.
It's as simple as unthreading this castle nut.
Correct. Yep. And then this is the inlet adapter here. This is what would be changed out to operate this on one of our many tools.
Okay.
So this actually also houses the seal that seals against the high pressure water. You can see the input of the shaft right here is very small.
Yep.
And the seal is inside of here. We actually have one right here we can look at. This is the backup ring. There's an O-ring that seals around the outside of this, and then this plastic high pressure seal would sit up against this backup ring, and the shaft would go through it like this. Okay. And so this would be fixed, and the shaft can rotate inside of there.
So the seal, the backup ring, the inlet adapter, all of those things are stationary, and the shaft is what's providing the rotation.
Correct.
Okay. And how does that rotation happen, Anthony? I mean, in some instances, we can build these things or set them up so they're self-rotating. In other instances, we build these so that they're driven by either an air motor or a hydraulic motor or an electric motor. What are the advantages of one of those types of drive mechanisms over the other?
Well, sometimes you don't have access to air on your pump unit. So if you don't have access to air or hydraulics, then you would want to have a self-rotating version of it. The self-rotating version works well, but it's really nice to have control over the rotation speed. Sometimes this can go up to 3,000 RPM, but 3,000 RPM is a little bit harsh on the seal, and the seal life is reduced. So if you can slow it down to 2,000 RPM, you can extend that seal life much longer.
Yeah, that's a great point. You obviously need to spin it as fast as you need in order to get your job done. But if you can back off that rotation speed a little bit, you can see dramatically longer seal life.
Yeah.
Okay, so that's the DS8850. Let's talk a little bit about the DS8800, which was the swivel that was in existence before this one.
Yeah, we have the shaft and some bearings here for the DS8800.
Okay, and we're comparing that to this for the 8850.
Correct.
Okay.
Correct. And actually I have a DS8850 shaft here, and you can see that the bearing arrangement is different. We have 4 bearings on the new style of shaft, yep, and just 2 bearings on the old style. And the old style has this really large bearing. You only need one when you have a larger bearing, but this forces a larger body and the tool becomes heavier. This is used on one of our rotating hand lances.
Right, handheld.
So, handheld.
Yep.
So that's a lot of weight to hold on to.
Sure.
So we came up with this design with smaller bearings. There are more of them, but they're smaller, and they take the high force from the 40,000 psi at the inlet, and they transmit, the bearings allow that, support that force into the body.
Okay.
So if you don't have as many bearings, the bearings can wear out. The stack of bearings reduces the load on any individual bearing.
Okay. So when we went from the 8800 to the DS 8850, one of the things we changed was the bearing alignment or arrangement. Why, I mean, what else did we do, or why did we go from the 8800 to the DS 8850?
That's a great question, Jim. The DS 8800 had this seal with an O-ring on the seal.
Okay, the O-ring was actually part of the seal or pre-installed on the seal?
Correct. And effectively, this reduces the length of your seal. As this seal wears, it's gonna work its way in. So having this O-ring here reduces that length of seal life that you have.
That's a great point, Anthony. I think let's talk a little bit about seal life and seal wear, because really what happens is this seal kind of extrudes itself past the backup ring and past the shaft. And eventually when the seal fails, a lot of times there's just a portion of it left.
Correct. I actually have one here that's got about 30 hours on it, and you can see that it's not nearly as long as what it was originally.
Right. So it sort of consumes itself through the seal life until eventually there's nothing left and it's time to put a new seal in.
Correct.
All right. So as you mentioned, one of the key goals in going from the DS 8800 to the 8850 was seal life.
Correct.
We wanted to provide something that would give our customers longer seal life than they were experiencing.
Right.
And we were successful in doing that. So, Anthony, where do we find these? We talked a little bit about the hand lance, but there's a lot of other places in the NLB product line that uses this type of seal. What are some of those tools?
Well, we have 13 different versions of this tool, depending on which inlet and which output that it has.
Okay.
So this is used on we've got a self-rotating spin jet. We have a self-rotating surface prep, our SRT 6LT.
Right.
We put a self-rotating spin jet on our microarm Mark II. We've got various end-of-arm tooling, hydraulic-driven, air-driven.
Starjet trucks.
Starjet trucks, that's a big one.
The SRT 10, in addition, had one of these. So
yes.
Really, any place you're finding rotating ultra-high pressure today in an NLB product, you're looking at a version of this seal.
That's correct.
All right, Anthony, thank you very much for stopping by and talking with us about the history of the ultra-high pressure swivels and why we build it the way that we build it. Next, we're going to be joined by Mike Whitehead, who is going to help us understand some of the ways that we can better maintain these to get optimal seal life.
All right, thanks for having me, Jim.
Thanks, Anthony. We're now joined by Mike Whitehead. Mike is our lead technical service contact. So if any of you have called NLB to talk to anybody about how to get the best service and life out of their equipment, out of your equipment, Mike is typically the person you may have spoken with. Mike, tell us a little bit about yourself.
Well, I've been with NLB for a little over 25 years. Previously, before NLB, I worked for an industrial cleaning contractor where we use NLB tools and other high-pressure water tools.
All right. So Anthony was with us earlier, and he gave us some of the background about the design and evolution of our ultra-high pressure swivels. But what I'd like to talk to you about today is some of our customers' experience with our ultra-high pressure swivels and what you've been able to help people learn about how to properly maintain and run these. In front of you here, we have our DS 8850, which is the modern swivel. How does someone know if a seal is nearing the end of its life or if they're going to need to be able to change that seal soon?
Well, the best indicator of a worn seal or needing to change it soon are weep holes that are designed in that would start leaking at the point the seal becomes too worn.
Okay, so there's small holes that go from where the seal sits inside of this thing outside or to the outside of the swivel, and once water starts to come through those holes, that means that seal is starting to fail and there's some water getting past it.
Yes.
And that water would literally kind of drip out of this area between the retention ring and the castle nut?
Yes.
Okay. So a customer sees that and they say, it's time to change my seal and my swivel. What do?
Well, they would just simply, after they shut off their high pressure water, they would remove this castle retaining nut
No tools required.
No tools required. And they would then remove their whole seal housing.
Which is the backup ring, the seal, and the inlet adapter.
Correct. You have the inlet adapter. There's the high pressure seal is inside the adapter. There's an O-ring groove inside the adapter, and then the backup ring.
Okay. So you remove that, you pull this part out, and then what do you do next?
So at that point, you would just disassemble your seal housing, which is just removing your backup ring. Every new swivel, as well as any new tool that has this particular swivel on it, would come with a plastic O-ring pick and an aluminum seal removal tool.
And it's important to say at this point, people really should be using these tools to do this work, because if you were to use a metal pick and you were able to somehow scrape or gouge the inside of that assembly, you would create a situation where seal life would be vastly reduced.
Yes, it's very important for the areas that the seal comes in contact with to be very clean and smooth, because if they're not, that gives water a passageway around it.
Okay, so you've got your backup ring, you've removed that, and if someone needs to remove the seal, how do you do that with one of these tools?
If you need to remove the seal, it's just a plastic seal. It looks just like this. It's sitting down in the housing. Your tool is threaded very similarly to a bolt tap, and you would literally just thread your tool
Into that.
down into your seal. The threads would hold it, and you would just by hand pull it out.
And then once the seal is out, then there is the O-ring.
Correct.
And that O-ring.
Once your seal's out, you would use your plastic pick to pick out your O-ring.
Okay.
And then reverse process, going back together, you would put your seal in. Important to note that there's a bevel on the backup ring and a bevel on the seal, so those two surfaces meet each other. So the flat end of the seal goes into the seal housing first. Then you would lube your O-ring. That way when you put your backup ring in, it reduces the chance of you damaging the O-ring when you put in the backup.
Okay. So the procedure for putting a seal back in is putting the seal in, then putting the O-ring in, and then installing the backup ring.
Correct.
And when you install that backup ring, you want to make sure that that O-ring is in its groove, and that just the simple act of pushing that backup ring past that O-ring doesn't cause it to get cut or damaged.
Correct.
Yeah. Okay. So once that's done, you simply put that back and slide it over the shaft?
Well, one step I would do, a common point of overlooking for most customers, is the importance of also having the shaft clean.
Great point. Yep. You can have a brand new seal and a brand new backup ring, but if there's some residual seal material left on that shaft and you put it back together, it's going to wear much quicker.
Correct. The most common way to clean that off would be to use some abrasive pads such as Scotch-Brite, a small piece on your finger, pressed against the shaft, and then turn on your rotation just to buff off that shaft. Gives you a nice clean new surface for the seal to ride on.
Okay, so you're literally talking about cutting a little piece of Scotch-Brite that you can just hold against that shaft with your finger and let that thing spin a little bit, and that'll get it back to a very, very clean surface. Great.
Yeah, at that point, you would just wipe a little bit of anti-seize onto your housing, slide it back in the hole, tighten your nut. Very important to not use tools when you're tightening your nut. Make it as tight as you can by hand.
Okay.
Release the retaining sleeve, back it up to the nearest possible engagement.
Okay, great point. Field repairable, no tools required. Don't use tools, as a matter of fact. Tighten it up as much as you can by hand, then release that retainer spring and back it up until it locks together.
Yep.
All right, I see a grease Zerk fitting on this, Mike. What's that for, and how does that play into?
Well, you have bearings on your shaft. So with any bearing, you need lubrication. These are open bearings, so when you grease your grease zerk right there, the grease gets forced into the housing, which will lubricate these bearings, which will increase the lifespan of your bearings.
Okay, so best practices at the end of a shift, when someone gets done with the hand lance, it'd be worth putting a grease gun on that zerk fitting and giving it a couple pumps of grease. And
Correct.
all right, great. So Mike, in your experience, when you have customers that contact you and they're concerned about the seal life in their 8850 swivel, what are some of the things you start to look for or talk to them about?
Well, we'll start to find out what are some of the details of their tool, like what their application is. Are they spinning the tool too fast? Do they have a hose coming in? If it's a rigid mounted application, if there's a hose coming in that's creating stress on the inlet side of the tool, those things can lead to shortened seal life. You know, the condition of the bearings, there's multiple factors. Most commonly would be outside influence, like the hose moving, or when through the process of them changing their seal, they neglected to make sure they have clean surface on their shaft.
Okay, so most typically, short seal life would be, it could be that the shaft wasn't clean before they put the new seal in. It could be bearings starting to fail, although not nearly as typical. I think it's important to kind of go back to one that you just said there, because if you think about something like an end of arm tooling application where this thing is mounted on a robot and that robot arm is doing all these kind of things, and you have a hose, and anybody who's used 40,000 PSI hose knows how rigid that hose can be. If there's a situation where that hose is putting an undue amount of drag in one direction or the other, that can really start to impact seal life negatively.
Correct. The only other thing would be if at some point the tool suffered some kind of trauma, like the head on the tool coming in contact with something while it's rotating, which could bend the shaft. And if the shaft gets bent, then you have run out on the seal area, which could lessen the life of your seal.
Right. And I want to go back to one thing you said, because it's not as obvious to a lot of people, but if you're around these things, it becomes more and more obvious that if you're turning this seal faster than it needs to turn, so if you've got somebody who's just turned the air motor up to 100 and this thing's running at 35, 4,000 RPM, your seal life is going to suffer dramatically.
Correct. Yeah, if not necessary to run the tool above 2,000 RPM to efficiently clean whatever you're cleaning, then running it at a lower RPM will equal longer seal life.
Yeah. So viewers, that is probably the biggest secret to longer ultra high pressure seal life, is only rotate that seal as fast as you need it to do the job. So Mike, for anybody that owns a tool that has one of these seals on it, what kind of spare parts would you recommend they keep on hand?
Well, the main items that you need for your high pressure swivel would be your high pressure seal, your backup ring, and your O-ring.
Okay.
Those should be nearly daily maintenance. It would be recommended for every 3 seals that you change out 1 backup ring. That's just a guideline. You can obviously look for wear on your backup ring, and you can look for premature seal wear, and that could determine if you need to change your backup ring.
Great point. So if you have a new backup ring and a new seal, and you put it all together and you get great seal life, and then you put the next seal in and you get great seal life, and then you put the next seal in and all of a sudden the life is half of what it was, the next step would be to change the backup ring.
That's correct.
Or the backup surface. Yep. Okay, so really for most people you're talking about O-rings, seals, backup rings. For someone who maybe wanted to have a little bit more assurance that they would have everything they might need, we could talk about replacement bearings. Although those really, as long as they're lubricated and greased, those last a long time.
That is correct. So maybe a long-term job, I would recommend maybe 1 set of bearings to be available on your job site. The swivel is field rebuildable, so you don't need anything other than basic hand tools to change out your bearings. So it would be a wise thing to have on a long-term job.
Yeah, that's a great point. And we talked with Anthony a little bit about why we went from the 8800 to the 8850. And you had mentioned earlier that in that shaft design, you actually have to press that bearing on and off that shaft.
Correct. So that was one major improvement over the two models of the swivels, is you would need a press for the bearings of the old swivel, whereas the new swivel, the bearings can literally go on by hand and are just retained with a nut.
Okay, great. All right, well, thank you, Mike, for joining us today to talk about NLB's ultra high pressure swivels and how you've been able to help customers get extended life and get the best experience possible out of them.
Yeah, my pleasure.
All right, and thank you all for joining us for this latest edition of NLB's Tech Tip videos.